In 7.3 we talked about part-to-part ratios and proportions. In 7.4, in this section, we're going to talk about how we can solve part-to-whole ratios and proportions. So we've been keeping track of that whole, that sum of the numerator and the denominator, the two parts. And in this section it's going to be really useful because these are going to look familiar, but they're going to be worded slightly differently. So let's do the warm-up question here. It says answer the questions below. Be sure to find the scale factor and show your work. It says the ratio of the songs on Addie's iPod to Cameron's iPod is 7:4. If Addie has 9,492 songs on her iPod, how many does Cameron have? So let's go ahead and set up this ratio. So we've got Addie's iPod to Cameron's iPod, and that's 7:4. So Addie's got a lot more. And it says Addie has 9,492 songs, and we don't know how many Cameron has, but it's definitely going to be less. So one thing we could do is we could figure out what the scale factor is here, which we'll do in a minute. We can also figure it out by solving this using proportions. So let's do 7x on this side. We're going to do 4 times 9,492, and then we're going to divide both sides by 7. Okay, so we get x equals, and I'm going to grab the calculator and pull that up. We're going to type in, again, I'm going to do this entire numerator in parentheses, always a good idea. So we're going to do 4 times 9,492, and then we're going to divide that entire thing by 7, and let's see what we get here. We get 5,424. So 5,424. So that's the number that goes right here. So Cam has 5,424 songs. So we'll go ahead and circle that. That's the answer. Now, if we wanted to figure out what the scale factor is, you'll notice that we've been doing this quite a bit. We take the big number that corresponds with this small number right here, and we just do a little division problem. So let's do 9492, and let's divide it by 7, and let's see what we get here. So we'll do 9492 divided by 7, and we end up with 1356. So I'm going to write down 1356, and that right there, that's the scale factor. Now let's see how this is useful. If we multiply this by that 1356 to get that big number right there, we're going to take this reduced 4 that represents Cameron's songs, and we're going to multiply that by 1356. So I'm going to grab this, and I'm just going to type this in, and let's see what happens when we do 4 times 1356. So I'm just going to hit times. It's going to use that last answer, and I'm going to multiply by 4. Now if we did this right, it better give us 5424, and that's kind of the cool thing about checking this way, is we've got this automatic built-in double check where we can say, okay, I can solve it one way, and then I can double check it really quickly another way. So 5424, that's the right answer on that one. Okay, and then the next one, it says for every $3 Noah makes, Nicole makes $5. If they make, holy cow, that much altogether, how much does Nicole make? So we're going to do 3 to 5, and then we're going to do all together. So this is going to be part 1, and we're going to do part 2. So this is going to be a 1, and this is going to be a 2. So Nicole represents the 2, and then this is going to be the whole. This is going to be all together. This is going to be 8. So if they make this much all together, so we need to figure out what these numbers are right here. And we can do this 196008 in order to figure that out. So let's figure out what the scale factor is. So we're going to do 196,008 divided by 8, and we're going to get the scale factor on this one. So let's see, 196,008, and we're going to divide that by 8, and we're going to get 24501. So 24501, that's the scale factor. Whoops, let me put a box around that so we can keep that straight. That right there is the scale factor. That's how we go from these small reduced numbers to the big numbers. So let's multiply by 3. So let's do that number, so times 3. So we end up with 73,503, 73,503, and I'm going to change colors on that one, 73,503. And let's multiply 5 by that number. So we're going to do 5 times 24,501, and we end up with 122,505. So 122,505. So it says, how much does Nicole make? Well, this represents, that's number 2. That represents Nicole right there. So Nicole makes $122,505. That's pretty cool. I would like to make that much. So let's see. We've got that built-in double check. So let's just see if we got this right. Let's take that answer and then let's add that 73,503. And if we did that right, we should get the 196,008, which we did. Okay, so we're in good shape right there. Okay, so that's a good warm-up right there. We've been using these ratios and proportions, scale factors, and all that sort of stuff, figuring out that scale factor, making sure we answer the question. Now, the problems that we look at today, they're going to look and sound very similar to the ones that we did last time, but there is a slight difference. We can use the exact same concepts and skills that we did before. As with all ratios and proportion problems, we're going to be sure to find the scale factor and put a box around it on each one of these. Okay, so here's a thought question for you, and you're going to need to be able to answer this question or figure this out in order to do today's problems. So it says 5 out of every 9 chips is yellow. What is the ratio of yellow chips to red chips? So again, back to that 2-color chip activity that we did. So it says 5 out of 9 chips is yellow. Well, 5 out of 9, so it doesn't tell us how many red there are here. So in this type of problem, we call the 5 a part, okay? And we call the 9 the whole. So what we're going to need to do is we're going to need to find the other part. So let's write it down this way. So part 1, or the yellow ones, are 5. We don't know what the red is, so we've got yellow, we've got red here, and we've got the whole. The whole is 9. So 5 out of 9 chips is yellow. Well, what that means is, remember, we've been adding these 2 parts together to get the whole. Well, they just gave us the whole. They didn't give us both of the parts. So in order to figure out what this missing part is here, instead of adding these 2 together and getting the big one, we're going to take the big one and subtract the part that we have. So 9 minus 5 is 4. So what that means is there would be 4 red ones. So it says, what is the ratio of red chips to yellow chips? It would be 5 to 4. That would be our answer right there. And that's really the key here, is on many of these problems, they're going to give us the whole and one of the parts, and we have to figure out what the other part is, and we're usually going to do that with subtraction. So I'm just going to write down subtract right here. Okay, so let's slide down here and take a look at this one. It says Mandy and Amy have a collection of rocks. Mandy found 3 out of every 4 rocks in the collection. Together they have found 200 rocks. How many have each of them found? So Mandy's part, let's see, Mandy found 3 out of every 4 rocks in the collection. Now notice that it's not saying Amy found 4. Mandy found 3 out of every 4. So the whole is 4, so let's do a little subtraction problem. 4 minus 3 is 1. So if we were just looking at the 2 parts, Mandy found 3 parts to every 1 part that Amy found, and that's 4 parts altogether. And it says together they have found 200 rocks. How many have each of them found? So this is going to be 200 right here. So let's go ahead and find that scale factor. Let's do 200 divided by 4. We end up with 50. There's our scale factor. So we're going to multiply by 50 here, and we're going to multiply by 50 here. 3 times 50 is 150. And 1 times 50 is 50. And again, just that double check, 150 plus 50 is 200. So we think we've got the right numbers right here. And it says, how many have each one of them found? Okay, so Mandy, whoops, spell that correctly. Probably ought to capitalize it. Mandy found 150. And Amy found 50, and there's our 200 altogether. Okay, so we're in good shape there. So again, same type of skills that we worked with before, just slightly different in their application, and figuring out, they gave us the whole and one of the parts. We've got to figure out the other part. So here we go. There are 1,050 students at ERMS at Elkridge Middle School. 4 out of 7 have a smartphone. How many students have a smartphone? So 4 out of 7 have a smartphone. So have 4 out of 7. So what that means is the whole group is 7. So that means do not have 1. That would be 3. So, whoops. 4 have one, 3 don't. So that means 4 out of 7 have one, 3 out of 7 do not have one. And it says there are 1,050 students altogether, and it says how many students have a smartphone. So what we're looking for is this number right here. That's what we want to find. But we actually have to use that scale factor idea and the whole part right here. So we know that altogether there are 1,050 students total. Okay, not that have a smartphone, not that do not have a smartphone, but just total. So let's figure out what the scale factor is. So I'm going to do 1,050 divided by 7. So we'll grab the calculator again, clear that off, move this over just a tad. 1,050 divided by 7, we get 150. Okay, so 150 is the scale factor. So we're going to multiply by 150 here to get this number and 150 here to get that number. So let's go ahead and pull the calculator up again. So we're going to do 4 times that scale factor of 150. And we get 600. So this is 600 right here. And we'll do, if you know this one, that's awesome. 3 times 150, you could just do 3 times 15 and then add a 0, 450. 450. So how many students have a smartphone? So we would say 600 have smartphone. Whoops. Smartphone. Okay. All right, there's the answer to the problem. And again, always a good idea to double check. If I take 600 and add 450, I end up with 1,050. Let me show you one other thing that's kind of cool while we've got the calculator up here. We know the reduced fraction is 4/3. Watch what happens if I type in 600 and then I enter this as a fraction over 450. Now, if we did this right, this is going to give us a reduced ratio, a reduced fraction, and it should be the same as the one that we've got over here. There's our 4:3. So we're in great shape there. We know we've got the right answer there. Okay, next one. A group of 7th graders voted for their favorite sport. 1 in 8 voted for hockey. There were 256 votes cast. We could probably throw in the word all together. How many voted for hockey? So here we go. So hockey, not hockey, and then the whole, or in other words, all together. So hockey is 1 out of 8, so that would be 7 did not vote for hockey. I'm going to make that look a little bit better. And there were 256 votes cast altogether, so this would be 256. So again, let's figure out what that scale factor is. What do we multiply 8 by to make 256? We'll do 256 divided by 8. If you throw that in your calculator, I think we're going to end up with 30. Whoops, I need to hit divide. Make sure I did that right. Hit divide and hit enter. Yeah, I think that's going to be 32. So 32 is our scale factor. So we're going to scale up by 32 on each one of these. We're going to multiply by 32, multiply by 32. So we end up with, let's check and see. Well, 1 times 32 would be 32. And then I need 7 times 32. So we'll do 7 times 32. Hit enter, 224. Okay, and then the question was, how many voted for hockey? Well, it just turns out that those are the ones that voted for hockey, so it's 32 voted for hockey. Voted for hockey. All right, so there's the answer. Just so happens that on this one, the answer to the problem is the same as the scale factor, mostly because that's a 1 right there. So on D, students attended the No Tardy Party and 11 of 18 students won a prize. So it looks like more than half of them won a prize. If 217 did not win a prize, how many did win a prize and how many attended altogether? So there are actually 2 parts that we need to answer right here. So let's go through and set this up. So we've got 11 out of 18 students won a prize. So let's do W for won a prize. And then let's do, let's say N for did not win a prize. And then I'm going to do WH here for the whole. So if we said 11 out of 18 students won a prize, that would be 11 out of 18. 18 is the whole, 11 of them won. So we're going to have 11 out of 18. So that means the ones that did not win a prize, that's going to be 7, because remember those have to add together to be 18. And then we're going to come over here and we've got these 3 numbers that we're missing. So we need this number, this number, this number. So up here, this is the number that won, this is the number that did not win, and this is the ones all together. And it says if 215 did not win a prize. So we've got either position 1, position 2, or position 3 that we need to put that 217 in. Those are the ones that did not win a prize. So that 217 needs to go right here. So I'm going to put 217 right there. And then we want to figure out the scale factor. So let's do 217 divided by 7. We'll pull the calculator up. 217 divided by 7. And we end up with 31. So we've got 31 here. So 31 is the scale factor here. That's going to help us figure out what each one of these numbers are. And then I'm going to grab the calculator to do the 31 times the 11. So we're going to do 31 times 11. And we end up with, let's see, 341, so 341. And then we're going to do the 18 times 31, so 18 times 31. Hit enter, and we get 558. So this is 558. So we've got all the numbers in here. Now 11 plus 7 is 18, but let's just double check. We've got this automatic double check. We produced each one of these numbers by doing the scale factor, multiplying by 31. So let's just make sure that, let's see, 217 plus 341. And let's just make sure that works out to be right. It's 558, so it looks like we're in good shape. So how many won a prize? 341 won a prize. And let's see, 558 attended. Okay. All right, so we got that part taken care of. And now, it's the last part here. Elkridge Middle School will welcome 156 new students this year. 5 out of 13 will be boys. How many more girls will enter the school than boys? Okay, so 5 out of 13 will be boys. So we're going to do boys, girls, and then the whole. We said 5 boys out of 13, so that means this number right here has got to be an 8. Remember, those need to add up to be, the two parts have to add up to be the whole. And then I'm going to put a little line here. We have 1, 2, and 3, and it says they will welcome 156 new students this year. Well, 156 new students, they're not boys or girls. They're both, either one, all together. So this is going to be 156 right here. So we're going to take 156, divide by 13, grab the calculator. I'm going to clear that off. We got 156 divided by 13. Hit enter. And we've got 12. So that means the scale factor on this problem is 12. So we're going to multiply each one of these by 12. So if I do, let's see, 5 times 12, I end up with 60. If we do 8 times 12, we end up with 96. And we've got 60 plus 96, that is 156. And it says, how many more girls will enter the school than boys? So the girls are this one, the boys are that one. So we're going to do 96 minus 60. And we end up with 36. So we're going to say 36 more girls than boys. All right. Before we move on to the other problems we're going to do, I'd like to take another look at this problem right here and point out that on this one it said 5 out of 13 will be boys. So 5 are boys out of the 13 total, so we figured out the 8 right there. And how many more girls will enter than boys? So one thing that we could do, they're basically asking what's the difference between the number of boys and the number of girls. And I want to show you one other way that you can figure that out. If they ever do ask what's the difference between the parts, you can do this. I'd like you to take a look and figure out what the difference is between the 5 and the 8. These are the reduced parts for the boys and the girls. So 8 minus 5 would be 3. So 3 is the difference between the two of these. And then don't forget that the scale factor is 12. So watch what happens if I multiply by 12. If I multiply by 12, I end up with 36. And lo and behold, 36 is what the difference is between the two of those. And if there were more girls than boys here, there are going to be 36 more girls here than there are boys here. So it's just another quick way that we can kind of find an answer of something that seems really difficult, but it turns out to be not too bad if we check all these relationships between these. All right, we're going to take a look at number 1 and number 17. So here's number 1. It says 1 out of 8 students voted for Jackson. The other students voted for Morgan. If 56 students voted for Morgan, how many voted in all? So how many voted in all? That is a question about the whole. Okay, not either one of the parts, but a question about the whole. So 1 out of 8 students voted for Jackson. So 1 out of 8 for the whole voted for Jackson. The other ones voted for Morgan, so that one must have been 7. So we've got Jackson, we've got Morgan, and we've got the whole. And 56 voted for Morgan, so that's going to go right here, 56. So the total here is 56. So now we can figure out what the scale factor is. Let's take that 56 and divide it by 7. We end up with 8. So 8 is our scale factor. So we're going to multiply by 8 here. So that's going to be 8. And we're going to multiply by 8 here. That's going to be 64. And notice that 8 plus 56 is 64. And it says how many voted in all. So this is our answer right here. We want to know how many voted in all. 64 voted in all. Okay, so we've got that answer right there. And then let's slide over here to problem number 17. Let's check and see what this one's got in it. It's got an asterisk by it, so we're going to need to be careful with this one. It says for every 7 games the Grizzlies played, they won 6 of them. If the Grizzlies won 30 more games than they lost, how many did they win? Okay, so this is a tough one. They're telling us not how many they won or lost. They're saying they won 30 more than they lost, and then it's asking how many did they win. So we've got to think about this in kind of a clever way. For every 7 games the Grizzlies played, so that's how many they played, they won 6 of them. So let's do win, loss, and then let's do the total or the whole, okay? So for every 7 games, so out of every 7 games, they won 6 of them. So that means they won 6, they must have lost 1, okay? It says if the Grizzlies won 30 more games than they lost, how many did they win? Let's see here. Well, they don't tell us either one. They don't tell us how many games in total they played. They don't tell us how many they won or lost. They tell us how many more. They won 30 more than they lost. So on this one, it's going to be helpful to figure out what the difference is. Okay, the difference between the two of these is 5. So instead of doing the total, I'm going to do the difference. The difference is 5. And they're telling us that the difference is 30. They won 30 more than they lost. So let's think about what the scale factor would be here. So the scale factor on this one would be 6. So let's times these by 6. So if I times by 6, I end up with 36. If I times by 6, I end up with 6. And if I times by 6, I end up with, so times by 6, times by 6, times by 6, this is 42. Okay, 36 won, 6 lost, 42 games altogether. So that looks good. And we've got 30 more, 36 minus 6 is 30. So this is the number right here. So it says how many games did they win? They won 36 games. Okay, so I'll write 136 games. Now, this is one of the few where it's not a bad idea to write that little table if it's helpful. So they won 6 games and lost 1. Okay, if we kind of double that, they'd win 12 games and lose 2, win 18 games and lose 3, win 24 games and lose 4, win 30 games and lose 5, and 36 games and lose 6. So what we're looking for is the difference here. The difference between the two of these is 5, 10. In fact, let me put that 5, 10. This would be 15. Notice how that works out really nicely. This is 20. This is 25, and this is 30. That's the one that we're after right there. Again, a tough one to do there. All right. Good luck with the assignment. You've got several that are much easier than this, and then a few that kind of do the same type of thing as this. If you need to use a chart, use a chart. Scale factor is great. Again, notice how many we did here. 1, 2, 3, 4, 5. 6 different boxes right here. So the scale factor would be 6, and then we've got this extra one to solve there. Good review problem right there. All right, good luck.